All right, does every quadratic function, so this is in standard form, ax squared plus bx plus c, have x-intercepts? If yes, prove it. So when we have x-intercepts, that is when y is equal to 0. If we're trying to show whether they have x-intercepts, we can solve for x when y is 0. So we could use our function at 0, ax squared plus bx plus c. If I set y equal to 0, that's going to help me solve for my x-intercepts. It's easy when it's in factored form, but when it's in standard form right here, the only way to solve for your x-intercepts is by using the quadratic formula. So the quadratic formula states x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And that'll help us solve for our x-intercepts. So we'll get a value here where x is some, we can call it some value, I don't know. We can call it alpha and 0, and then we may have a beta and 0. Those would be our x-intercepts. But do we always have x-intercepts is the big question. Is there always a guarantee that we could have x-intercepts? There's a couple different options. Well, here's one quadratic function that has 2 x-intercepts. Here's another quadratic function that has no x-intercepts. And here's the last one that has only 1 x-intercept. Okay, so the question is, where did we get the alpha and the beta? The alpha and the beta just come from our x-intercept form. And that's if your function is factorable, then we could factor it and identify our x-intercepts. Not every case will have a function that we can factor. So if we did not have a factorable function, so if we had this standard form and we could not factor it, we would have to use the quadratic formula. Okay? So to get 2 solutions or 2 x-intercepts, now you want to think about your quadratic formula. How can you get 2 solutions or 2 x-intercepts? How would we get 2 answers to this problem here? Well, since we have a plus or minus, we just want some value to happen with b squared minus 4ac. If we get that to be a number, then we have a plus or minus a number. Is that okay?
Yeah. So if it's positive?
So if it's greater than 0, then we have 2 solutions.
Oh.
If it's a positive number.
Is that for like all things?
What do you mean?
Like if it's always greater than 0, then it will always have 2 solutions.
Yeah, if this whole value right inside here, if that is greater than 0, you'll get some number. And the 2 solutions come from this plus or minus. Yep, and that's why you get plus a number or minus a number, so that's why the 2 solutions happen. To get no solutions, you would have to have b squared minus 4ac. How would we get no solutions from our quadratic formula? Yeah.
You would have to do, it would have to, oh my gosh, be less than 0.
It'd have to be less than 0. It has to be a negative. This is what it's less than 0. So if I calculated this and I got a negative number, b squared minus 4ac, you can't have a negative square root. So it ends up with no solution. And to get 1 solution,
Equals 0.
yeah, we want b squared minus 4ac to equal 0. So there's our 3 possibilities. And because this number underneath the square root is so special, it has a name called the discriminant. So b squared minus 4ac is the discriminant. That identifies whether you'll have 1 solution, 2 solution, or 3 solutions, or no solutions. And where those solutions happen. If it's 2 x-intercepts, 0 x-intercepts, or 1. So when you're matching the 3 graphs with their possible solutions, right here, it's solved for the x-intercepts. This is the quadratic formula. So to find out how many x-intercepts, all we really care about is this value under our square root. So if we look at that value for this for letter A, that's 16 minus 4 times 2, which is 8, times 2, which is 16. That is 0. So if I solved for my x-intercept, I would have negative 4 plus or minus 0 over 4, which would give me negative 4 divided by 4, so negative 1. That means I have only one x-intercept, so that matches with number 3. For letter B, if I look here, in the middle I have 9 minus 8 times 2, which is 16. I end up with a negative number. We cannot have a negative square root. This would be no solution, which would match with number 2. And this one, it's 9 minus 20 times 2, so plus 40, yeah? That's going to give me a positive number, so I'll have 2 solutions for that one. It's number 1. So when we're trying to find out how many solutions or roots or zeros, all we really care about is our discriminant, which is the number underneath our square root. So b squared minus 4ac. And as we mentioned before, there's 3 conditions. If b squared minus 4ac is 0, then we have only one solution or one x-intercept. If b squared minus 4ac is less than 0, then we have no x-intercepts. And if we have b squared minus 4ac is greater than 0, then we have 2 x-intercepts. Right, the equation k, x squared plus 3x plus 1 equals 0 has exactly one solution. So this is written in standard form. It's ax squared plus bx plus c. If it's equal to 0, then we know that we are finding our x-intercepts. If it has one solution, that tells us something about the discriminant.
Yes.
The discriminant will be, which is b squared minus 4ac. If it has one solution, it has to be 0. So now we can substitute in our values. We're solving for k. So let's see. Instead of b squared, I would put in 3. So I have 3 squared minus 4. Instead of a, I put in k. And instead of c, 1. I set it equal to 0. Now I have 9 minus 4k equals 0. Move over my 4k, I could have 9 equals 4k. Divide by 4. So k has to be 9/4 in order for the equation to have only one solution. Okay, the equation x squared minus 2kx plus b has 2 distinct real roots. If it has 2 distinct real roots, that means b squared minus 4ac has to be greater than 0. So if we identify this as ax squared plus bx plus c. So to find all possible solutions, we substitute in our values. So b is everything, it's the coefficient to x, so it's everything in front of x. So b squared would be negative 2k squared, that whole term in front of x. Minus 4, our a value is 1. It's not written there, but it's there. And c is 1. We want that to be greater than 0. Yes.
I'm confused. Can you explain how you got to that?
Yeah. This is where things get tricky. We end up with 4k squared minus 4 is greater than 0. And if we were to solve for k, I can add 4 to both sides. I get 4k squared is greater than 4. So k squared is greater than 1. So what is k? K has two solutions. K can be 1, or k can be negative 1. We have an inequality, so we have to think about our number line, and we have to test points to figure out where these solutions would hold true. It cannot be equal to 1 or negative 1, so we have an open circle there. And now we test points on each side of the interval. So you could test a negative 2. If I put negative 2 in here, negative 2 squared, is that greater than 1? Yes, this is yes. So that means I would shade here. I put in 0. Is 0 greater than 1? No. Then we put in a value like positive 2. Is 2 squared greater than 1? Yes. So for this one, we could have many solutions. We could have all of our negative values until we get to negative 1, or we could have 1 until infinity.